Welcome back. In fact, we are doing a topic that's a subtopic under Surds that I almost wanted to ignore. I almost ignored it because we have been doing this often over and over, and I assume, in fact, not assumption, I know that you know because we have treated them under different topics, and in fact, in this particular episode that we are going to do, we have already looked at it in the properties of surds, right? So the general properties basically talks about the multiplication of surds. It covers the properties, but as I promised that we are not leaving any stone unturned, I have to do it anyway so that when going forward, I wouldn't think otherwise. So if you are new on the page, we are treating chapter 4, that's surds in core math using AKI-OLA textbook. This is for SHS students, those in school, those who want to go and write remedials. In fact, it will even be better or beneficial to those who are now about to go into SHS, right? School. It will help them as a pre-SHS what lessons. So now let's go straight to the point. So we are saying that when multiplying two sets, the following rules of sets must be used, which we have already looked at. Point 1, square root of a times square root of b will give us square root of ab. We are multiplying things, items, constants, variables under the square root signs. So since a is under the square root sign or the radical sign, b is under square root sign, so all of them will be under it. So typically using numbers will be this way. I know you know them now. Now point 2, we know that into brackets, square root all squared will give us what? The same variable, the same constant, which is this 2. But if you want us to prove it, then this is where we expand, segregate, and then we combine them back into one particular unit. So we have squared, we expand them, square root of 2 times square root of 2. This is how it is done. And then giving 4. And then this 4 actually is what? 2 square root of 2 squared. So square root of 2 squared, which the square root sign cancels the the power of 2 here. So 2 raised to the power 2. That I know I'm not doing this because we have done that already. I think I'll bring it up when we get into doing more complications under the multiplication sign. So stay tuned. In this particular video, we'll do that. Now, so with examples, the same thing here, we have that. But what it means is that if you are familiar or abreast with the formula, you don't have to go through this process, because in OBGs or MCQs, there's no time on your side because you know the property and you are sure, you are certain. So when you see something of this sort, straight is 2. Is the number there. Is the number of variable, the same variable, the same constant. That is it. So 2. For 3 is 3. You see, for 5 is 5. If you want to prove this, where you go through the process procedurally, you go through that. So that is it. So in general, we have this giving you that. Now that is it. Now, if you go down to point 4, a times square root of b. So what it means is that a is multiplying square root of b. We told you there was or there is an imaginary multiplication sign. Now this is it. So they have actually introduced it for you to see. But in calculation, when you become a master of art of the calculation of the subject, or in fact the topic, you wouldn't need to bring this, because we know that it is multiplying. For demonstration purposes, they had to bring multiplication sign. So it's the same as a square root of b. So in practice, you have 2 times square root of 3, which gives us 2 square root of 2. We told you this 2 is what? The multiple, right? The rational multiple. This 2 is called rational multiple. In front of the square root sign or the radical sign, we call it what? The multiple. Now, also consider this, right? So I wouldn't worry much here. let's go deep. Okay, we can actually look at it. So 2 square root of 3, 2 square root of 3, and then times 3 square root of 2. So we are multiplying outside constants and then multiplying those under the square root sign. So that is it. Now I wouldn't waste time here. Let's do some practice, right? Let's do some practice. So stay tuned. So now this is example involving a number of constants or a number of terms, right? We told you we learned about terms. So we have how many terms here? 1, 2, 3, 4. So one bracket, another bracket, and this whole bracket is multiplying this bracket, right? Or this whole bracket is multiplying this. So that's where we introduce the expansion, multiplying them back to get what it is. So I should even demonstrate without actually doing the calculation, but because I still don't want to leave things vague or any stone unturned for the benefit of the doubt, I will still do it in practice. Now going forward, where we are going to deal with the division of multiplication of surds, I am not going to be taking things from scratch. So now bear in mind, in the division of surds, that will actually usher us into another special calculation under surds called what? Rationalization. So the division will come later and probably be the last topic or video under the whole of this chapter. So stay tuned. So now, this is the question, right? This is the question, and we are going to do it here, right? So if you see here, we have this one into bracket square root of 3 minus 1 bracket close, and another bracket open 2 minus square root of 3. So what it means that we are going to multiply this by this, and we have learned already in expansion and quadratic expression, trinomials, factorization, we have done that. So what it means that this particular item is going to multiply this one, and then this one is going to multiply these two items. So square root of 3 multiplying these two items, and then 1, negative 1 also multiplying these the two items. That's why I've shown some arrows. So this one comes from under here, it comes to multiply this one, then this one also comes to multiply. The same thing will be done for negative 1 multiplying this one, and then negative 1 multiplying negative what? Square root of 3. So let's do the expansion. Now, since we are doing the multiplication, then square root of 3 multiplying 2 minus square root of 3, right? So when we are done, then this negative 1, right, we'll also do the same multiplication, right? So if you do the multiplication, square root of 3 times 2 will be 2 square root of 3. Now you know why it is so. Now square root of 3 times negative square root of 3 will give us this, right? So we now look at it very carefully, this. Then we come to this one, we'll multiply this one, giving this one, then this one multiplying this one. Negative, negative give us positive. So positive square root of 3. Then coming down, we have this. This actually means what? 9. And when it is that, you can go back to look at it here, right? You see that here. Hence, the answer is going to be what? 3. 3 here, right? Then this one comes down the same way. So now we get 2 square root of 3, negative 3, negative 2, plus 3, plus square root of 3. So if you do the calculation, the answer will be 3 square root of 3 minus 5. Do that, and you see that the answer is correct. We'll see the next one. Bye for now.